Hello guys, welcome to Digitronix Nepal's tutorial session. Actually, we are making different tutorials on mostly FPGA and microcontrollers uh, from past 3 years. So this is our almost I think first tutorial on ISE Design Suite. Actually, we don't make ISE Design Suite based tutorials cause of we are working on Xilinx Design Suite and latest FPGAs, while ISE Design Suite is it almost on phase out state because Xilinx doesn't have updated the ISE Design Suite from past 2 years. I think 14.7 is the last revision of ISE Design Suite, and so we are focusing on latest FPGAs like system on chip FPGAs like Z-board, Zinc, family, and Pink FPGA, and other like RTX, Kintex, Vortex family. And so we are also making video tutorials on ISE Design Suite regarding to the some complication of ISE itself. So however, in many areas like industrial areas, manufacturing areas, and academic sector, ISE Design Suite has been using or is using still. So we are making this tutorial. So this is our very basic tutorial actually. So in this first tutorial on ISE Design Suite, actually we also have different tutorials on ISE, which is covered very less on ISE, and we are focusing on like Spartan 3, Nexus 3 FPGA board. So this is the getting started ISE Design Suite tutorial on Spartan 3, which is actually focused on Spartan 3 FPGA. If you have Spartan 3, then you can follow this tutorial. So it will be effective for you. If you have different FPGA board, it will also cover those FPGA boards also. So let's let's review on this tutorial some plan. We have make a plan. In this tutorial we are going to see the very basic like complete example. So starting from like RTL or SDL to implementing the design on FPGA. So we will design and get in VHDL, and we can see also on Verilog also. So and we will create a test bench. Actually, test bench is a term for simulation script of VHDL. Actually, test bench might not give you a specific information. So creating simulation. Test bench for AND gate, and we'll also create a constraint by method of plan ahead by manual. Creating user constraint file and following plan ahead. There are two type of methodology for creating constraint, and we will also generate PT stream, not only the implementing and generating. We will generate the PT stream, and we will test the very basic AND gate into our Spartan 3 FPGA. So you can also visit our website Digitronix Nepal.com and YouTube channel. You can get lots of information regarding to FPGA and Xilinx ISE Design Suite, Vivaro Design Suite. Even we have some information of Altera Design Suite like Coratus and different FPGAs too. So let's go to ISE because we are focusing on ISE. We also have installed ISE and Vivaro both in single computer, so we can use it's our interest. So let's go on ISE and go to new file, new project. So I would like to change my directory of projects. Actually, I have created another. Sorry, I have one. Okay. I have just given name of AND gate video because we are creating a video tutorial series. So we need to change this setting according to our FPGA board because these first 5-6 parameters determine which FPGA we are using. You can select actually from evaluation development board section also. If you have a Spartan 3 like starter board, then you can select this, or even you can change manually, like we need to have a Spartan 3E, and the device in Spartan 3 is XC3S500E of our device, and the package of our FPGA is FC320, and the speed grade is -4. So actually speed grade is the timing delay between the like on operation, value which is passing to another value, like we're using a less than equals to B or C in VHDL, which we takes that less than equals to operator actually need -4 nanosecond of delay. So this is the speed grid. Actually -5 speed grid is higher performance, so because it is in negative scale, so we can use for higher performance operation for -5 speed grid of FPGA. So let's select F-4 because our FPGA is -4 speed grid type. So you can also select like which synthesis tool are you going to use. We have only one, so XST VHDL Verilog is our, and we can also select simulator, because if we have different type of third-party simulator like Questa Sim, Model Sim, and different simulator, you can click those two, but currently we don't have those, so we are using default simulator ISIM. So you can also select power language, like we are powering VHDL, and we can also use Verilog too. You don't need to change anything rather this on this menu. So let's go to next. You can create a finish. This will create a just a project folder. Actually this project folder has been created in here, and there is no any significant sources, so we are going to add a new source of actually VHDL module. Firstly we will work on VHDL. So we will do next, and we can also assign ports as usual in this menu. So if we doesn't want to insert any ports in this menu, we can also skip it, but we are going to use ports at here, A, B, and C. Actually both are in input and another are in output, and it is in input. If we have any bus architecture, like if A is multi-bit, then we can use, like if A is 8-bit, then we should use LSP0 and MSP1, which is less significant bit is 0 and most significant bit is 7. So 7, 6, 5, 4, 3, 2, 1, 0. It is actually 8-bit data. So we are not going to use any bus architecture in this session. So C is in output, so we will get output from C. Let's use Z, which is sounds good. So the template has been created. Actually in this template, VHDL template, we can see the first two is libraries, like header file in C, C++, and in the second section there is entity section, and third section there is architecture section. Actually these library are header files, which actually determines this IEEE determines the what entity and architecture keyword signifies for. So this header defines entity and architecture, and in second stage there is standard logic 1164. Actually this determines the standard logic and input output standard logic data type. So this is data type. Actually standard logic is data type. Standard logic consists of 9 logic states, which we will show in next tutorial. So this 116 determines the input output standard logic, and IEEE determines entity, port, and end, architecture, begin, end, this type of keywords. So let's edit some very basic things on this section. So we already talked about this library section, which is header file in C, C++. This is entity declaration section. We talk about like some input output or variable declaration in C, C++, and third is architecture. We determine header files, entity, port declaration, and third in architecture. We actually write about what we are going to do, what is the operation, what is the architecture in this section. So let's work on this section. We will insert our main architectural algorithm in in between begin and end behavior. So if you have any signals like temporary variables or any like components, then you should declare those scripts on this section architecture and begin. So between architecture and begin, and we will going to do like geod is very less than equals to a and b. This is very basic, so we are just talking about how is the flow of creating from HDL to implementing an FPGA. So let's save it. So we can save all sources. We have only one source actually. Then we can do a synthesis of it. Actually synthesis process check the syntax and it generate the RTL, actually register transfer label circuit diagram like schematic. So I have just left A, so let's do it. And so RTL schematic is actually a schematic circuit diagram of this HDL. Actually these HDL compilers like synthesis step create a schematic from language HDL. So let's view a schematic, very basic schematic. So let's click on this. We can see the AND gate. Even we can go to inside of it. Sorry, this is our AND gate. We can also create zoom to full view. Okay, this will create a full page of our schematic. So we can close it. We don't need to any work on that schematic. So let's add another source of AND gate in Verilog. So we are going to talk about Verilogs too. And the both languages are very useful and efficient and used in hardware designing. So we are also giving some hints to you in both languages. Actually VHD is the extension of VHDL and .b is the extension of Verilog. So this is the same process, A, B, and Z. We are going to set output. So let's do next. It actually create a port declaration as in VHDL. We already seen about here. Here is port declaration. So everything is declared in this module section, because in very simple program Verilog is very easy to understand because it is a successor of C programming language, while VHDL is successor of ADA. So module and get we have these inputs, input A, input B. We can also declare with input A comma B comma output Z. So we are going to do what we are going to do is assign in this stage. So before end module assign Z equals to A. Actually there have different operators or sorry, we are creating AND gate, so we should use ampersand A and B. Sorry. So this is the Verilog syntax. So we can also check this. We can make this top module for synthesizing. Okay, let's synthesize it. We can see similar RTL from this Verilog too. Actually this Verilog is I think revision of 2001. In 1995 revision we should also insert different type of port variables. Then after we only declare about orientation of variable, but in 2001 revision we should care about module name and what are the input output parameters directly, and we will in the module input output parameter main, and then we assign what we are going to do, and after that we will take in module. So let's actually this is similar to previous one, so there is no significant difference between Verilog. And if we create a OR gate in Verilog, then this is the OR symbol, and we can also create like a XOR. This is XOR. Let's check on XOR. The complexity of program determines how much time is synthesis or implementation is taking. So let's see RTL of XOR. This is XR. So let's zoom out. So this is XR. Actually XR, XR means A bar B plus AB bar. So actually A bar B plus AB bar, there might be, there is not this one input, this another. We can even zoom it. Okay, we don't care about what the article is. So we are going to synthesize the VHDL initially. So for synthesis, so it need to be make a set as top module. This three rectangular box determines which is the top module. Means top module have priority to do further stages like implementation, like synthesis, like generation. So we should make it top module. So let's do on VHDL. So this is extra module which we are not going to use in this top module, so they are different. So let's add another source of VHDL test bench for simulating VHDL script, VHDL AND gate. So AND gate underscore TV would be the good name for this. And let's select, this is not our actual source for AND gate, this is our AND gate. So we are going to select VHDL of AND gate. So let's do next finish. It will create a script of simulation test bench. This is also similar to the previous main script. So actually we are creating AND gate. AND gate is actually a combinational type of gates which actually converts or combines different inputs and gives the output. So we don't need to have any clock, like gate combination logic are not clock dependent. So we will remove, or we will comment. Actually double minus is comment in VHDL. So we will remove every clock processes, like this process is not also required. So let's remove it, and we will also not going to use this. And even we can also comment it by using double minus. So in AND gate we need to give the condition of inputs, like A must be starting at 0 and B must be starting at 0, and we need to have wait for 100 nanosecond of delay. So we are going to copy this section and paste it into 3 times more. So actually AND gates have 4 stages. So let's change the value. Sorry, other are good. 0 0 0 1 1 0 and 1 1. This is simulation script of VHDL. So you must be clear about we are just simulating VHDL. If we simulate Verilog also, it might be confusing. So we are not going to do further process on Verilog. So this is simulation script of VHDL. So you can also see the extension .vhd. So we will close it. We will also remove it from here because it might make confusion onto you. So we have create the VHDL program for AND gate and create a test bench for AND gate. So we need to simulate this test bench, isn't it? So we already have synthesized the main VHDL program. So let's re-synthesize it. Then after we will switch our radio button of implementation to simulation, because we need to simulate this script of four different steps. So let's click on simulation of ISE Design Suite. Actually this ISE Design Suite is of 13.2 version. I just forgot to tell you about. So you might have 14.7, which is also similar because we have used 14.72 sometime. So you don't need to be curious about what will be the difference. They are from similar company and similar tools. And we need to simulate this AND gate underscore TV is actually signifies for test bench. So let's expand iSim simulator and let's check the syntax of this program. If we have make any mistakes, yes, there are some mistakes. Let's go to error. AB syntax error near. Okay, I just get it because it there need to have semicolon. I just forgot to put it, isn't it? So let's save it. Let's recheck the syntax, then after we will simulate. Let's double click on simulate behavior model. Actually this is ISIM simulator. If you have different simulator, you will get to select option in this menu. So this is the simulation waveform of AND gate, very basic gate. So we also have prepare VHDL, Verilog and Tickle reference guide. We have also included this process in those reference guide, but for subscription of those reference guide, you need to have a subscription method with us. We provide subscription coupons, so you can get download. So let's click on zoom to full view. It will give this full view. So this is mouse, you can click anywhere, it will give you the mark of where you have clicked. Like we have clicked on 84.320 nanosecond of delay from 0 to this value. So there is value of A is 0, B is 0 and output is just to 0. So if you have A 0, B 1 and output will be ending of A and B, so 0. There is A 1, B 0 and still Z is 0. So you can see Z is 1 in while A and B are high. So this is the main logical implementation of AND gate in simulation. So let's close it. You can also take a screenshot of this menu and use for any documentation. So we are going to close it. So let's again return to implementation menu. So we will follow further stages, which is further steps are implementation, generation and configuring target device. Even if you need some typical feature, then we can have typical. So let's we already have talked about, like we have simulated the AND gate, so we need to have constant for A and the AND gate. So there are two different methods of constrainting or writing constant for AND gate or any logical ports. So we need to have two methods. So one is manually creating and another is plan height. So we are going to use actually plan height initially, because that is quite easier than writing manually. So go to user constraint and click on floor plan area IO logic, but it is quite it takes some time for opening the program. So let's go to how to do it manually. So let's add another source. We can use manually also. Let's create implementation constant file. Let's click on here. So let's go to net. Actually we have port A, location equals to, what is the location of A? The location, the constant is specific to your FPGA board. So you should care about what FPGA you have and what are the constants for normal GPIOs for your like switches, LEDs, buttons in your FPGA, and this you must be care about. So we are using, actually if you type S, then it is the comment. We are using Spartan 3 FPGA development kit. So this constant is only valuable or this constant only targeted for Spartan 3 FPGA kit, which consists of XC 3 years 500 FPGA device, isn't it? So let's have a location. So we already know about some location of Spartan 3. So let's type is L13. We can close it. Another is we can copy this section. And one tips to you, if you are using Spartan 3, then you should care about one thing. You should download UG230. Actually that is user guide for Spartan 3. I need to open it, but I haven't. Okay, I will show you in later. So this will be B and this will be Z, and I will take two inputs from L13 and L14 and we will display it on F9. So Spartan 3A UG 230. See, user guide from Xilinx. So let's open user guide. So this user guide must be with you. If you don't have, you should download it. If you type UG230 in Google, then you will get this user guide. This is of only, I think, is 3 to 5 MB. So on download, so let's go to switch button and LEDs. So we are giving inputs from these two switches, L13 and L14. Actually that are SW0 and SW1. So here is also constant. We can use this constant. Actually we have typed this values on our constant set, so we can also replace this by line. So let's copy it. We can also copy it from here. So let's paste it. This is A and this is B. I'm going to comment on constant which was written by me. Okay. We can also insert this in last. These are the constant and these are the comments. You should constant, must be careful about this. So we also need another output. Actually we have provided A and B as input because these switches can give us input. These are input device and we need to have output. So let's go to next session. Button also are input devices. We need to have output device like LEDs. So these are 8-bit LEDs. So here is constant of LED. So let's copy first line. We can also write ourselves this line. So let's go to constant UCF set. So let's paste it. So we just need to replace this section. Actually we have to replace with 0. So I have saved it, and we should click on this. We will do implementation, we will do generation, and we will do configuration of our target. So this is very short and sweet tutorial session on ISE Design Suite. Let's have some time with this implementation. There are sub processes like mapping, translating, and placing and routing. These are the sub processes of implementation. Actually this implementation stage did synchronize these logical ports. These are logical ports with this constant. These are physical ports. So these logical ports will be synchronized with or connected with these physical ports. So if we have make any errors like syntax errors, then it will have some error, but currently our design is very fine, so there are no any warnings, no any like errors. So let's generate programming file, and in this stage these two program will merge, and like bit stream will generated, which will be useful, or which will use on programming the FPGA. So generation is also successful, and we need to have to go to configure our target device. Actually we don't have connected our FPGA currently, so this stage we just show you how you have to do the configuration. Go to boundary scan and right click on here, initialize jet. If you have connected the board, then board will appear here. Currently we don't have connected our board. We will show you how to program FPGA with PT stream from ISE Design Suite in next tutorial. So after clicking initialize chain, you will get 3 devices here. First one is FPGA, actually XC3S500D. Second one is PROM, that might be up to some 2S series of PROM, and third one is CPLD. So you need to click on S, then you will get the first device loading option. So you will create you will need to double click on .bit file, current bit file from this directory. Actually you should have one directory. Then in second option you can click on bypass, then you should clear apply and OK. Then then you will get the program option, then go to FPGA, then right click on it, then create, then click on program. So this will show you message program succeeded, and you can also see on your FPGA by saying like program laid must be blank. So if that is blank, then your program is successful. Then you should test your program by making these two switches L13 and L14 in different stages, like 00, 01, and 10 and 11. If you do 11, then your layered actually we have used which layered? We have used F9, so F9 must be blank. So this is the overall flow of designing very basic logical gates in ISE Design Suite. This is also easy tutorial, so which we already have prepared this tutorial on Vivado Design Suite. So you should migrate from Vivado from ISE, because ISE is almost going to be phased out very soon. So guys, this will be the overall tutorial on this session. So if you don't have UG 230, this is user guide 230 of revision 2006. Any revision would be good. So download Spartan 3 user guide or user guide of your FPGA board. Then you should make a constant planning at here. Then you should program it as we have talked about. So guys, almost we are at the end. So we are thankful for your support and views. So keep subscribing us, keep commenting us. What type of tutorial do you need? You can comment on our tutorial session commentary box. So we will meet you again in another tutorial session. Thanks for watching. Thanks.